Forsythe here. I hope that you've watched Miss Pittman's video from earlier in the week where she explained what magnets are and what they do. Today we're going to go a little bit deeper and we're going to talk about the relationship between magnets and compasses. If you've done the Nearpods that are posted on your STEM Clever account, it talked about how Earth is one giant magnet, and so that's why that our compasses automatically point north. So if we're looking at this, we're looking, if I spin north for me, is back that direction behind me from my house. So we're going to see what effect a magnet has on these compasses, on the arrows. So when we're looking at it, we're going to be looking at the red part of this arrow. Now, let's do a little refresher. A magnet has two poles. These are marked on mine by color and by the letter. So you'll see that it has an N for north and an S for south, and that's the north and south poles. So what we will do is, if you look to the activity sheet to your left, I'm also posting this underneath in a link, but your activity sheet to the left has us laying the north side here and the south side here. And we're going to observe the compass arrows near our magnet. So it says to place, we're going to set it on the table and then place our compasses around like they have it in the picture. Look at the arrows in the compasses and observe which direction they point. In the circles in the activity sheet, we're going to draw our observations. Remember, we're looking at the red part of the compass. Get a little bit closer. Looking at the red part of the compass. So, if we'll look here, I'll fill it in on our sheet. So here, the red arrow is going in this direction. This one is going this direction. This one is going this direction. This one is going in that direction, and then the final one is going in that direction. Excuse my arrows as I'm doing this on a computer. Now, we're going to take a round magnet that Miss Pittman also described in her videos to see how this affects when we add it in. So we're going to take the round magnet and we're going to move it towards one of the compasses. We're going to observe the arrows. Now, on our paper it says to draw where we placed the round magnet. So I've placed the round magnet right about here. And I'm going to record my arrows. Now it appears as though it did affect the compass that I put beside it, but just slightly. It did not affect any of the other compasses. So I'm going to record my observations. Now, in this third and final part, we're going to talk about if we move this magnet to a different place. We're going to see if that affects the other compasses. Ooh. A little bit too close to my magnet there. So now I've moved my round magnet to this position. And now I'm going to record my observations. If I notice this compass up above the bar magnet went back to its original position before I put the round magnet there, and the magnet has now affected the compass that I put it right beside. But if you'll notice, there's not as big of a change as maybe we thought there would be. So the bottom three questions I want you to think about. What do you think the compass arrows show? What happened when you held the round magnet near? And why do you think these things happened? Based on what you've learned in your Nearpods about compasses and based on what you know about magnets, why do you think that moving the ring magnet affected these compasses? If you decide to complete this activity, make sure you add it to your seesaw so that your STEM teachers can see.